I'm Adam Rauch, as Bernie said, co-founder of LabKey, VP of Product Strategy. So Bernie just gave a great overview of our Biologics LIMS and the value that it brings to a wide variety of organizations. For those of you, I know many of you are already using Biologics LIMS, which is great. Those who aren't yet, we hope that you've been inspired or intrigued by what it has to offer. But you might be asking some questions. In fact, some people already asked questions about how does Biologics LIMS fit in with my existing informatics infrastructure? So you might have systems, I'm sure you have systems that generate data, store data, process data, act as sources of data for a system like Biologics LIMS. I'm sure you and your colleagues have a variety of data analytics and visualization tools that you use on a regular basis, perhaps programming languages, scripting languages that you use to process data kind of downstream of an integration system like Biologics LIMS. If you're asking those questions, this presentation is for you. What I've tried to do is illustrate through some concrete examples. I've tried to make it as real world as possible, showing actual scenarios and use cases from Biologics LIMS clients and how they have integrated their biologics with their infrastructure, with their enterprise systems. So this is kind of the key takeaway that I'm trying to convey. Hopefully I succeed. Essentially, Biologics LIMS Enterprise most likely already connects to the systems and tools that you already have in place that you use on a regular basis. And if not, we can help you. LabKey can and will work with you to establish those integrations and make sure that Biologics LIMS fits in with all of your systems and tools. So I kind of broke up this presentation a little bit arbitrarily into upstream systems and downstream systems. So when I talk about an upstream system, I mean essentially a source of data that will be flowing into Biologics LIMS. So systems that generate data, store data, process data, etc. So we'll start there, and then in a little bit, we'll look at the downstream systems. All right, so oftentimes we start, pretty much every one of our clients needs to migrate data from an existing system or multiple systems into Biologics LIMS. In many cases, that data resides in one or more relational databases within the enterprise. They might be scattered about the enterprise, each with a different function. But Biologics can connect to each and every one of those databases and, in a secure manner, and extract the data that is needed to bring into Biologics. So that works through a function we call an external data source. So a very simple configuration for each of these data sources gets added to the Biologics LIMS. It supports a wide variety of, pretty much all the popular relational database servers that are out there. And once configured, the data that has been configured, the schemas and tables that have been configured can then be immediately accessed through the Biologics user interface. So all the standard functionality that works with built-in tables and schemas. So viewing grids, sorting and filtering, writing SQL queries, visualizing, analyzing, writing reports, exporting, using APIs, all of those facilities become available on these external databases. And importantly, for this migration process, you can define one or more ETLs that essentially run either on a single point or over time on a recurring schedule, perhaps nightly or on a regular basis, to synchronize and refresh data into Biologics. So you can define a variety of external data sources, a variety of ETLs that pull that data and transform that data into a structure that makes sense for your analysis and the integration within biologics. For data that does not reside in a relational database, we have some other facilities. The ability to import data in a wide variety of formats. So Excel, text formats like tab separated values, comma separated values, etc. We support lots of different formats, specialized formats as well, for importing into Biologics LIMS. So this process would then be you export from the system, the existing system, and import into Biologics. And that can be automated via APIs and scripts if desired. So sequencing information is obviously very key to this type of R&D. Again, Biologics LIMS makes it easy to register nucleotide and protein sequences, whether they're coming from files or they're coming from sequence engineering software such as SnapGene, Genius, etc. And this is really just a process of importing FASTA files or GenBank files through the Biologics UI. So that looks like this. Here's a GenBank file. In the user interface, I simply clicked on Add Import File, Import From File. I dragged my file, or I selected my file from the file system in this user interface and clicked on Import. And there are my sequences. You can see down below here, the nucleotide sequences are, and the protein sequences imported and appropriately linked, and then made available within Biologics. So that's the import process, fairly straightforward in getting these types of data into the system. So very important. You most likely, almost certainly have instruments and instrument data that needs to be integrated into Biologics, imported, and then integrated with the rest of the data within your experiments. We support a very configurable assay framework for this purpose. You configure what the assay requires in terms of columns, in terms of data types, in terms of what that structure of data looks like. You as an administrator can configure that and then import either on a one-time basis or on a regular recurring basis. So Biologics can actually, if needed, infer that assay structure just by looking at the data, can kind of recommend based on that inference what the structure should look like. You can then modify that or update that based on what you actually need. So manual import, as you saw with the sequences import, manual import, that's always a possibility. That's a good place to start. But you really want to think about for these cases where you're importing on a regular basis, multiple, many runs over time. You can establish a fully automated data capture process using what we call a file watcher. So basically, you define a trigger that watches a certain location in the file system. Let's say a folder in the network file system where an instrument drops its results on, say, a nightly basis. You then specify a pipeline task to launch on the files that match the files that you want to import. For instance, in this case, we'd specify an assay import as a pipeline task. With that set up, all the files generated by that instrument are automatically imported into Biologics whenever they appear. So it might be in the middle of the night. Biologics will see that file has appeared and automatically import into the system. And then, so LabKey includes a wide variety of built-in pipeline tasks. But importantly, you can develop your own if you wish in a variety of popular programming languages. You can develop custom pipeline tasks. Perhaps you've got a customized format that comes off of an instrument, or specialized QC of transformations that you need to perform on that data before import takes place. You can write that code. You can develop your own pipeline tasks and integrate them into biologics. So that pipeline trigger process looks something like this, just a kind of a two-panel wizard where you specified names, locations, the types of tasks that you want to launch, and as you can see, there are a variety of other settings that can control exactly what happens to data once it appears and is recognized by the system. Another very popular integration that our clients have performed is on their existing electronic lab notebooks. So systems like Benchling, LabVantage, et cetera. Our clients have established integrations with those tools to synchronize or do a one-time migration of data into biologics. The approach is very similar to what I talked about with legacy data systems or migrating from existing data systems. Essentially, our clients configure an external data source to connect to the underlying database behind these applications. And then they define an ETL to pull the desired data from that ELN database into biologics. And again, ETL can be configured as a one-time operation or on a recurring schedule to provide regular synchronization. And then some clients have taken it a step further by writing code that transforms that ELN data into a structure that better matches what they desire in their schemas. So finally, some other popular integrations within the enterprise. These are less to do directly with biologics and more about kind of enterprise systems. So very importantly, kind of those last two, integrating with enterprise level authentication and authorization systems. That's pretty key. So if your organization has Active Directory or an LDAP server that provides authentication and tracks users and groups, those can all be used and synchronized against biologics. Likewise, if there's an enterprise single sign-on system in place via SAML or CAS, that can be integrated as well. And then on the file system side, no doubt you have local and network file systems, store a wide variety of data. LabKey can be configured to manage those. So we provide great general file management capabilities. So perhaps you have protocol documents or publications, results in a variety of different formats, policies and procedures, any type of document in a wide variety of formats. You can manage them via the user interface, both downloads and uploads. Every file that LabKey has available to it will be indexed for full text search purposes. Pipeline jobs can be launched on these files to process and import the data. And we've talked about file watchers. And interestingly, getting more and more traction is Amazon S3 object storage. So we have an integration with S3 that supports most of those file system capabilities I mentioned. And we have a facility we call a cloud watcher that works in much the same way as a file watcher, where S3 can be configured as essentially a drop location, and biologics can watch that location and process files, objects that get created within S3. So I'm going to take a short look at these questions. And
yep, I think we have 3 or 4 good ones in here that are probably worth talking about. So one question that was asked previously during my presentation was asking a little bit more about incremental functionality. Some of the functional differences between our Biologics LIMS Starter, Biologics LIMS Enterprise. Everything that Adam is talking about is part of our Biologics LIMS Enterprise. And while some of the things he's talked about in regard to assay data and some of the other features that I described that are built in are part of both, a lot of these system integration tools, SSO, S3, that he's talking about, even here, are part of our enterprise offering. And just to make clear a little bit more about the scaling and growth from one of these products to another, or from a small size up to a larger size institution, we do our best to price in a way to support your growth. So for small organizations that might just want a few users, or maybe want 20, 30 or something like that, we can offer per user pricing to make in categories. So you're not going to say I want 7 specifically. It's up to 10, up to 25, up to 50, like that, so that you can scale some without having to return to us for any kind of contractual changes. But we also offer unlimited users, annual cost as opposed to per month cost to help with that scaling. I also see specific questions about file types. Adam, I heard you talk about things like GenBank and FASTA files and other ways in which we manage. We allow you to manage sequences that might be moving between systems. This question is about AB1 file types. So this is DNA electropherograms. We actually currently do not support that specific file type, but we add support for new file types all the time. This is something that we do quite regularly. And so if it was important for you to see that electropherogram data integrated with everything else in the system, that's something that we could talk about doing fairly easily. There's also one here about how you associate automatically imported data with existing records in the database. Adam, I can let you take this one, but at a high level, when you have sample information registered in the system, we join everything based on that sample identifier, the sample identifiers in the system. So when you automatically bring in new information, if it has that sample ID or an existing alias, we will automatically connect it. Adam, I don't know if you wanted to say a little bit more technically about how that works, but you're certainly welcome to.
Yeah, I think that's a great example. A couple key things here. When you define a file watcher, you define exactly where in the system that data is going to end up. So kind of partition-wise, where exactly, based on experiment location, based on other factors, you control where that data goes. Also, the target of that import is going to be, let's say it's an assay structure. It defines foreign key relationships, potentially. You have that ability. And so that's one way that you would then link, because the incoming data, if it has, as Bernie mentioned, sample IDs, for instance, or some other identifier that links to existing data in the system, those will automatically get linked up through those foreign keys.
Okay, and then there's one more question on here, if you don't mind, really fast, Adam.
Sure.
It's a question about common assay types, common assay import methods, and how do we make it easier for groups to implement who have lots of common assay types. Yet we internally maintain a large library of those assay designs, as we call them. Not everybody needs all of them, so we don't necessarily shove them all down your throat when you first sign up. But we have a set of designs available that you working with your account manager can figure out which ones are of greatest utility. Put those on your server, update them to more closely suit your needs, and move on from there. We also have helped people compose parsers for unique instrument outputs as needed. Sometimes it's because the shape of the data is slightly different in some critical way, and other times it's because people want to see something different based on that data in the system. And so we ultimately construct ways of viewing that data that are different than something that's a little bit more cookie cutter. And I'd invite you to talk to us in a little bit more detail outside of this presentation to dive into some of those specific cases.
All right, so I do want to touch on what I've labeled here, the downstream systems. So again, this is data analytics and visualization tools, languages processing that takes place sort of after integration within Biologics LIMS. And again, we have many different options here. The first kind of basic option, kind of the workhorse, is you can always export your data. Any data that you've imported into Biologics, you can export with the click of a button into a variety of very common, ubiquitous formats. So Excel, text formats, etc. We also support a number of more specialized formats for specific types of data. We have a folder export capability that is very powerful. It conveys all of the data within a given partition within LabKey, and you can use that to copy the data, publish the data, archive it, load it into another server, or process it downstream. So a lot of different export formats that are always available. Your data is never locked up when it gets into Biologics. One of the more popular integration techniques is via tools, analytics applications that support an API called ODBC. So many client applications and servers support this API, and that gives us the ability to gives you the ability to use those applications directly with Biologics. So via ODBC, these tools can connect directly to Biologics and pull live data into the tool for analysis and visualization purposes. And if that data changes, it can be refreshed immediately within that application. So you can see kind of the list here. I know Bernie has mentioned Tableau and Jump as being very popular with some of the Biologics clients. Jump, for instance, we just added a couple of weeks ago, direct integration with Jump. So we're adding these over time. Every month or so we add a new one based on demand from our clients. If someone says we need integration with Jump, then we look at that and investigate and integrate it. So these are coming all the time. So yeah, MATLAB, Tableau, SSRS, wide variety of tools that support ODBC. Another API that is used by some applications is called JDBC. So Spotfire is sort of the premier example here. Spotfire, of course, is a data visualization and analytics server. And again, just like the ODBC scenario, Spotfire can be configured with our JDBC driver to pull data directly from Biologics and analyze it, analyze that live data within Spotfire. And then via JDBC, we also support a number of other applications. And one option would be if You write a custom Java application, you can use JDBC to pull LabKey and biologics data into your application. Now, of course, all of these systems are subject to permissions and authorization. So all of them require a login of some kind, and that login controls what data the individual running that application is able to see. One of the most popular languages from our client base is R. And as you might imagine, we support R in a variety of different ways. So locally running R instances, R Studio Workbench, R Studio Shiny, R Serve. We have a wide variety of support for the R language, given its popularity. We've recently added direct integration with Jupyter Notebook through our Jupyter report. This is typically a Python-based system that can compose formatted reports and visualizations. Those can be integrated directly with Biologics. So Python programmers out there, you're probably familiar with this, and you'll I think see the value of having this integration, which was just added. Another Python integration is called Plotly Dash. This is basic. Plotly Dash allows Python programmers to create visualization web applications. LabKey's integration with it allows you to directly integrate with these web applications without requiring users to authenticate directly to Plotly Dash. So you can sort of secure your Plotly Dash application. LabKey provides credentials for the current user so that you can call APIs back in LabKey and pull the data that user is allowed to see, and know that they've been authenticated and have the authorization. So all of Biologics, for instance, is built on the LabKey API, and that API is available for programmers to use if they wish. Just a few of the capabilities that API provides. Provides the ability to query live data, to update and import and insert, and then manage users' pipeline jobs and permissions and assays and ETLs. So all of the facilities that I've been talking about are controlled via an API, and can be controlled by an API. And then the APIs then can be called from a wide variety of popular statistical and programming languages. So, all the usual suspects: Python, JavaScript, R, Java, etc. So this is the way that our clients extend Biologics through custom applications that reside on the server, or that reside outside of the server through in scripts or in separate web applications or separate programs. One of my favorite features, to kind of get you started with, for instance, querying data out of Biologics. You can use this handy export to script feature. In this case, I'm exporting to a little snippet of R code that, in this case, pulls down a particular assay results into an R data frame within my R environment, and then I can perform analysis or produce visualizations based on that data. And then finally, I want to talk just briefly about or provide some case studies, a couple case studies of how our clients have extended Biologics through the APIs and through their own applications that they've developed with our assistance. So the first example is a React.js application. It uses the JavaScript API. It runs on the same server as Biologics LIMS. and provides a custom workflow that associated with directed evolution of cell lines. So this is an example of a JavaScript application, resides on the same server, uses that JavaScript API to retrieve data from within Biologics. The second example is a separate Java-based JavaScript web application. So separate web application outside of Biologics that uses the Java remote API to access data within Biologics and provide custom functionality around that. So a couple examples, and in both cases, our clients did the bulk of the programming here, but we provided support and documentation and help and assistance to make these things, to make these applications successful. All right, so with that, we should see if we have time for a question or two.
Looking now, Adam, so far it looks like in that break in the middle, we covered what was available. For everyone, just a few more seconds here to pop a question in if they have an additional one, and you could take a quick breather. Okay, I think, there's one. Let's see. There's some permissions questions, security questions around extending Biologics LIMS. They want to know how you control data access if you have some kind of alongside or within web application.
Right. So for instance, that external web application that I mentioned, just like every other access to LabKey, whether you're exporting or using an API or using an ODBC client, it will require a credential or require a user and password, or we also support a facility called an API key, provides a little more flexibility and potentially security. So that needs to be provided, and that identifies and authenticates and authorizes a particular user. So that web application that I mentioned, it does need to uses an API key to authorize essentially the application as a particular user within the system. And then within Biologics, security roles are assigned to individual users and groups of users to define permissions. So we have a very flexible, robust, and powerful system for configuring access control within the system. And every single access to data is subject to those access control rules that are configured by administrators.
Okay, it looks like we have actually 3 more questions, but I think 2 of them are very closely related. One of them is about us developing, help us extending functionality versus clients independently doing so. And the other one is about doing so with some kind of private cloud, which I think I can answer quickly, and then I might send you the other one. We support extending functionality, building these alongside apps, either ourselves or having clients do it independently. So 2 of the examples that Adam just shared were applications built by client-based in-house developers. In their house. But we also very regularly engage with our clients to extend existing functionality or add new ones. And so, really based on your resources, we can accommodate it both ways. And then if Biologics LIMS is in a private cloud versus perhaps in our cloud, can people create their own modules and have them deployed to the server? Absolutely, in both cases. Obviously, the process is going to be very slightly different, whether you have full access to the infrastructure or if we do. But that's absolutely something that you can do in either case. And then I think last question here for you, Adam. The majority of examples you provide are one-way communication with other enterprise systems. Does Biologics LIMS provide two-way synchronization between existing infrastructure?
Yeah, I'm not quite sure how to answer that. There's certainly cases where I think the final applications that I highlighted where data is being pulled and then data is being pushed back into LIMS through the API. So obviously one example of that would be using the APIs to query data, transform that data, process that data, and then updating the data or creating new data within the Biologics LIMS. So usually that would be done through some custom code of some kind. So I think that's probably, I guess it'd be interesting to talk about the exact scenario in mind here. There's probably a facility available, depending on what the details of the scenario are. So.
Okay. One last question. How can we make suggestions for product enhancements and developments? There are lots of ways, but they all involve coming and talking to us about your needs. We would definitely love to hear those. Like I said, really enjoy engaging with people who want things to function in a particular way or add additional functions to what we have available. I would love to pick that apart with you and describe in greater detail how we work with how we field requests and support extensibility.